Welcome to Godot. Let's have a dialogue about dialogue boxes. My favorite genres have dialogue boxes, visual novels, walking sims, RPGs. But in Godot, most indie devs just kind of throw spaghetti at the wall and hope it sticks. They're like, this kind of is sort of like a dialogue box, that's good enough. That's kind of a shame because the nuances of a dialogue box are very similar to the nuances of everything else. So if you can do a good dialogue box, you can do a good everything else. The mechanisms you use to unfold your dialogue boxes are the same mechanisms you can use to unfold your boss encounters or script a scene where people talk to each other. Similarly, the UI that you use to create a dialogue box can be used to create any kind of UI. So let's talk about some good ways to create dialogue boxes. Here's what I'm going to give you today. Now, obviously, I'm just using some free Kenny assets for my pixel art here. If you are a pixel artist, you will be able to create much more beautiful dialog boxes, but I want to show you how to set these up. So, the first thing we're going to cover is the code, because I think that's the stuff that's a little bit more difficult for people to learn. I haven't seen anybody else really talk about this. You'll notice that dialog boxes have 4 phases. There's the fade in, there's the text display, there's the wait for click, and there's the fade out. Watch. See? So how do you make those 4 phases work? Do you have a bunch of functions? It's like when the player clicks, check if it's in this phase and do that. Well, that's kind of spaghetti code. I used to do that too, but there is a much easier way to do that, and that is to pray at the holy altar of await, the most powerful word in Godot. Let me show you some awaiting. Here's the script we're currently in. It's just this little scene with the background stolen from Dragon's Dogma. We pop it up, and here is our actual script. Await, say the Frog King, hubba trucka, hubba trucka, hubba trucka. Await, say the Elf Lord Beta, I am hooked on a feeling. Await, say everyone that you're in love with me. So await simply means that it will either wait for a signal or wait for a function to complete. So in this case, it's awaiting the function say, and here's the function say. It takes a character name, dialogue, and a face, and you can see that over on the right. Faces. All it does is instantiate the dialog box, set those values, and then add it to the screen. Then it waits for something called tree exited. Tree exited is a universal signal. Every node has this. It fires whenever the node leaves the tree, which is just the big scene, the screen in general. So when you delete it, it fires this tree exited. So essentially, say creates a dialog box, fills it out, pops it on the screen, and then waits for it to go away on its own. So this await ends up awaiting this dialog box leaving. Pretty easy, right? Now, this is an extremely flexible approach to handling general scripting in Godot. For example, it would be trivial to add in more stuff here, like random encounter B3, whatever, right? It's just standard Godot script, so you can script it however you want. And you don't have to await just this one thing. We can await other stuff like timers or players clicking or whatever we want. If you have an end boss with 3 phases, you can say, start phase 1, await phase change signal. Start phase 2, await phase change signal. Start phase 3, await phase change signal. Start final visual novel scene for denouement, because the boss is dead now. When you have these phases, it's much easier to just put them in a row in one function and use awaits. And obviously, this is super powerful for visual novel style stuff, since we could say, elf lord dot change expression, whatever, right? Whatever we wanted to do. This is also what powers the underlying way that we're going to handle the phases in Dialogbox itself, which is over here. This is what our Dialogbox looks like. Let's hit play. I always try and set up my sub-scenes such that they will be useful when you hit play. They won't break, they won't crash or anything. And in this case, you can see it runs with some generic filler stuff. So how does it work? Well, let's go in and take a peek. This isn't really a terribly complicated thing, but it does have a bit of mass to it. Let's talk about the stuff outside of Ready first. First, if you've never seen this class name Dialogbox sort of thing, class name allows this to be entered into the global registry of classes, which means that we can automatically fill in all of the properties and functions with tab completion. You can see us doing that over here in the scene demo, which is right here. DB character name, DB dialog, DB tree exited even. These are all things that exist in that class. So that's why giving it a class name allows us to fetch those things. And you can see us here as Dialogbox. And this setup here means whatever it actually is. So this DB is set up to be the Dialogbox. It's a simple trick. But that was just a useful thing to remember. You can name your classes and autocomplete will work. Here's our heartbeat. Signal next phase. This is a custom signal. So instead of something like tree exited, we create our own signal and we manually call it. If we actually look at the signal list, here it is, next phase. We can even set it up like any other signal. Connect it, for example. We can even give it documentation if we really wanted to. We don't, though. If we take a peek down at the bottom, we've got these three functions which help us to call that. So does the player press the space bar? Emit the next phase signal. Does the player click? Emit the next phase signal. Does the animation finish? Emit the next phase signal. So we don't have any sort of logic where we distinguish between what the player does and what the automatic underlying functionality does. We allow the player to override anything we do by just clicking. So here's how we do that. Here in Ready. Ready fires as soon as the node is ready. It's in the scene and it's ready to go. So this is all automatic. You just have to add it to the screen and this just runs. We set up the values as you usually would. You can see portrait, name, so on. We're using the standard approach these days, which is to access as a unique name. That's much easier than using get node and stuff. Then here's phase one, the fade in. We just await next phase. We are not doing anything though. So how is next phase ever going to fire? Well, our animation here in anim is set up specifically to automatically play fade in. Fade in is a 0.75 second long animation, and when it's done, animation finished will fire. And look, we've hooked that up to on animation finished, which is a function that calls next phase.emit. So this automatically will call next phase after 0.75 seconds because it's playing an animation that takes 0.75 seconds to run, and it's set up to call that whenever the animation is finished playing. Any animation is finished playing. So in 0.75 seconds, this will get triggered by the animation player. But the player, like the human player, may click first. 0.75 is pretty long, so they might, get impatient and click. If the player is spamming click, their clicks or their spacebar presses, or maybe you've got it set up for, rapid autoplay, all of that stuff will spam next phase, which means that we will get past this element without the animation actually completing. Therefore, we check if the animation is still playing. And if the animation is still playing, we play reset. Reset is an automatically created non-animation in the animation player that just sets everything to whatever you think the default should be. And in our case, that just makes everything visible because we don't want to have a partially transparent scene. Then we enter the next phase, which is just the part that the text starts to scroll out. Now, in order to scroll out the text, we just use a simple trick here where we go into this dialog text, and we're using this visible characters setup. We've got visible characters of 0, and we've got the visible characters behavior set to characters after shaping. The default is characters before shaping, which is always bad. Switch it to characters after shaping. That means that it won't, like, the words won't randomly change to a different line, and the lines won't randomly keep extending. So it works pretty well. And then what we'd want to do for actually listing all of this out, displaying it, is slowly increase the number of visible characters. Whoop, like that. See? So we just do that with a tween. A tween is just a way to automatically change a value over time, and in this case, we are tweening the property visible ratio of the dialog text. Now, the reason we're not doing that using an animation player is because we don't really know in advance how long we want it to take. We could try and change the animation player's speed, but it's generally easier in this sort of case to just create a quick little tween rather than trying to screw around with animation play delays and stuff. So we set up the tween property to tween this visible ratio to 1, which is all text, and it takes as long as this, which is dialog length divided by characters per second plus some buffer amount. And we also set it up to have a tween callback, which I know you're going to be surprised, but the thing that it does when it's done is it calls next phase.emit. Now, obviously, we await next phase, and this tween will call next phase. So if nothing happens and the player just lets it play out, this will happen automatically on a timer. But if the player is clicking or pressing space, they're going to get past this on their own time. Now, we want all of the text to show, even if the player is spamming past it. So if tween is running, that means the player clicked. So we stop the tween and we set the ratio to 1. Just like we did up here, it's the equivalent of setting this to reset. We don't want any half-finished lines of dialogue. Phase 3 is just waiting for the player to click. So in this phase, we do have the same sort of await next phase, but there's nothing that's going to trigger it. We have to wait for the player to click. There's no timer involved. We could add one. We could have like an autoplay option that waits 10 seconds or something. But in this case, we just wait for the player to click. And if the player never clicks, then phase 4 never starts. Phase 4 just plays this fade out animation, waits for next phase, and then deletes itself. The fade out animation is a very short little animation, but as before, we don't actually wait for the animation to complete. We wait for the next phase signal, which does happen when the animation completes, but it also happens whenever the player clicks. So this is a setup where the player can spam through these super fast. In fact, if the player has an auto clicker, they can get through the entire dialogue tree in 4 frames. So this is a very powerful way to set it up. And it's just one blob, one function. There's no logic here to check what phase you're in because the function is in the right phase right now. And this is a very powerful approach for a lot of basic scripting. I think I've already explained that, but it's critical that you understand that you can just use await like this. You can say do some stuff, await the result, do some more stuff, await the result, do some stuff, await the result. In fact, await is so powerful that you can do stuff like this. You can say var choice equals await menu pop-up option A, option B. And then your menu pop-up function can just wait for the player to click on one of these options and return the actual option clicked. So you don't have to farm out pop-up menus or dialog tree options to a separate function with a complex callback system, and you can just keep it all right here in this one chain. As long as there's no need to branch your code, there's no reason to branch your code. You can just always use await. Now, in this case, pop-up menu doesn't exist, so it's marked as an error, but this works fine if pop-up menu does exist. Now, I'm hoping that you understood all of that because I know that some people sometimes struggle with internalizing what this sort of code does. Await is the key word in question. Phase 1, we wait for a fade in. Await the next phase. Await the next phase. Await the next phase. Await the next phase. Sometimes the player calls it. Sometimes the timers call it. It just goes through. And because it's all funneled into one core channel, the await next phase signal, we don't care whether the player is triggering it or the automated scripts are triggering it. It works the same either way. It's wonderfully freeing to do stuff like this. So let's go ahead and take a look at some of the visual elements and talk about some of the tricks you can use to make your dialog boxes look decent. Now I say that, but I am, of course, using Kenny's free assets for this, so how decent this looks will depend on how much you like basic-ass pixel art. Presumably, you have some idea as to how you would like your stuff to look, and it may not be anything like this, but the basic layout is probably quite similar, so let's talk about some of the tricks we're using. The first and most basic trick we're using is, well, this is all a big button. You might have noticed that we do not do anything complicated like if input event is input event mouse button down with button left click mask equal 1. We don't do any of that shit. You might find tutorials that do, and those tutorials need updating because that is a bad way and an annoying way to do it. All we do is this on pressed. On pressed. How do we get on pressed? If you look, panels and stuff, they don't have an on pressed signal. There's no on pressed here. The best you can do is like GUI input, and usually you want GUI input plus something like a mouse entered and a mouse exit gate. Ugh, gross, right? Well, the answer to that is incredibly simple. You just make the whole screen a button. So this entire thing is just one screen wide button. Now the only part of the dialog box that's visible is this at the bottom. But that doesn't mean that the dialog box is actually constrained to the bottom of the screen. There is a giant invisible button that covers the whole screen. And the easiest way to make a giant invisible button is to use a texture button, because by default they have no textures. So they are invisible, but they still work just fine. You can see that if we come over here and give them a texture, there it is. Obviously, we don't want to do that, though. In order for this to work, we do have to set all of the values for mouse in all of these to ignore. So just to show that here, mouse, ignore. Everything here is set up to mouse, ignore, even this button. That means that regardless of where the player clicks, it's going to be clicking on the background button, unless something is popped up on top of this that catches it first. For example, a pop-up menu that says, which option will you take? Eat the baby or help people? So whatever you're trying to do, if you just want to have a pop-up menu that takes responsibility for the screen, you can just do this again with a pop-up menu that blocks off the entire screen so nothing falls through. It's a fun way to do it. This basic approach is incredibly easy to make work. It's so much easier than trying to figure out whether an event is actually being applied to the menu and whether it's a mouse left click. You don't need any of that. Now, when it comes to laying out the actual object, obviously it is a panel container and it has anchors at the bottom of the screen, like this. That means that regardless of how wide the screen is, it's going to be in the same place. But you'll notice that this panel container is not visible. This is an invisible panel container. And we do that because panel containers try to contain their children. Not only do they dictate how large their children should try to be, but if their children are too large, they will expand. So what we've created here is a bounding box. We could have tried to drag in this, off to the side here and off to the side here and try and make it the right size, but it makes it a whole lot easier if we just bound it to the edges of the screen, make it invisible, and give it some margins. It's just an invisible margin that we can do like this rather than trying to drag it pixel perfect. Then we use a VBox container, which I hope you're all familiar with by now. This is a vertical list of things because we have two things we want to have a list of, the name tag and the text. But you might notice that this doesn't really look like the standard layout for a vertical box container. Shouldn't there be like a 4-pixel gap between these two rows? Isn't that the norm? Well, why would you leave it as the norm? you should make the separation -20 pixels, and that'll work fine. Obviously. This is a very handy trick. You can set the separation to a negative value and your elements will overlap. Now this does mean that if we want the top element to be on top, we have to take some stacking measures. So if you'll notice, when we come down here to the panel container that contains the text, we have show behind parent turned on, which means that it will render behind this invisible panel container, which is obviously behind the very visible name tag. So that allows us to have the name tag on top, even though it is, technically speaking, behind the text. So now let's talk a little bit about how to create 9 patch rects. If you're just using panel containers, this isn't such a big deal, but 9 patch rects have a serious issue, and that is they're not containers. So if we were to try and create a new user interface with a 9 patch rect, no, that's not what I wanted. We can set up the 9 patch rect real quick, just like this, and then once you've got that set up, you come down here into edit region and you put the region in the middle like this. If you have never used a 9 patch rect before, it is quite simple once you understand what's going on. I'm not going to explain it here, but trust me, it's very basic. Looks fine, right? And we can put like a text box inside, right? And let's make the text really, really big. And we'll make this 9 patch rect black just so we can see the text. And then we'll type in some text. Set it to fit content so we can actually see it. Oh, it doesn't seem to like that very much. Let's turn off auto wrap. Oh, it doesn't seem to like that very much either. As you can see, without a container involved, nothing reacts. The 9 patch rect doesn't understand that the rich text label is growing, and so it should grow as well. It just renders itself because it doesn't care what its children are. So what we actually need to do is create a panel container. Now, a panel container automatically expands to fit whatever is inside of it, and that means that if we put in the 9 patch rect and the rich text label, the 9 patch rect will automatically also expand at the same time. Let's go ahead and make this invisible so we can see it better. You can see that now, if we change the size of the text box, the 9 patch rect will keep up. But we have an issue. The margins here are pretty bad. We really want the text to be inside of the 9 patch rect rather than on top of it. Like, this is just too wide and too big. It would be really nice if we could make the 9 patch rect bigger by using an expand margins theme, but these damn things don't get themes. You can't even make them skew properly. So this, we could try and put a border around it, but as it turns out, can we? Let's find out. Oh, well, we have to make a new style box empty so we can edit it. What do we do? How about 60, 30, 60, 30? Would you look at that? Just fine. Boom. Easy as. In addition, what we can do is we can try and make this 9 patch rect a little bit more flavorful. If you're doing your own pixel art, you can obviously draw it more flavorful in your art program. But because we are using one color flat sprites, when we want to make it more flavorful, we want to actually use layering. So to do that, we're going to just copy and paste the 9 patch rect. Let's make this one a different color so we can see it. Now, in order to make this track with the 9 patch rect, we're going to want to make sure that this is set to full rect so that it will always be the same size as the 9 patch rect. This anchors it to the same corners. But, as we have learned, the 9 patch rect is not a panel. It's not a container, rather. It does not understand how to contain its children. So we can just move this around, or we can change its size. So here's us moving it around, and here's us changing its size. We want to change its size like this. So let's make it bigger, like out here. But we really don't want it on top, do we? Well, we could make it smaller, or we could click this button down here. There. And now we have a little bit of pizzazz to our setup, such that we can get ourselves some nice layering going on. And we can also change this to a different texture if we think another texture would be better. This is very basic stuff, but you can keep going with this if you like, because there's no particular reason that this 9-patch rect has to be here. We could add more decorations. For example, how about a 9-patch rect that is on top, but is limited to the lower right-hand corner? Like this. And then we can make it like this. Oh, I just zoomed off to the side there. We now have a thingy that makes it pop out. And because it's anchored to the lower right-hand corner, when we change where the text is and how much text there is, it will track. See? You can actually use this to create the name box that we created, this thing here. You can just put it inside of a panel vector or some other non-container object. But I find that the VBox container is a little bit more reliable, so we use that. By the way that this is set up, the panel that is containing these two is set up to have an empty style box with a big left margin just to push it to the side a little bit. And then inside of that container is an H box where the portrait and the panel containers share. This is a fairly standard setup, but I figured I should mention it. So that's the basics of how to set all of this stuff up and do whatever you want and create whatever sort of boxes you want and set it up however you please. The only other trick I didn't really go over is this audio, which I just set up the audio so that when it finishes playing, it calls a function that starts playing again. How exciting. So this is also why I actually cue free the audio when I want it to stop playing rather than just telling it to stop, because there is a timer in here. And it's quite possible that I will tell it to stop when it's not actually playing and it's waiting on this timeout, in which case it will just resume playing a nanosecond later and continue to play forever until the player finishes the dialogue, which is kind of weird and gross. But that is just my own personal take on that. You are welcome to do it however you would like. I will say that there is one more thing we should discuss, and that is passing data to dialog boxes. I didn't do anything about this in this demo, but most of the time in a real game, you would pass the dialog box, the dialogue that is to be said, and a character object. Now, we actually don't do that. We pass it a character name and a character texture, which are two values that would be in a character object. Most character objects are resources that contain loads more values, like what sound should we play? What frequency should we use? What colors should the dialog box be? What font should we use? But we're not doing that here just because it would be a lot of extra boilerplate, and I don't really want to make you sit through that. But remember that you can create custom resources which can contain large sets of properties, and your dialog boxes can use those instead of manually passing every single value every single time. I think that's it. Hopefully you understood everything. If not, feel free to leave a comment down below. I will try and explain it. Here is what it looks like one more time. It all works regardless of how we spam it. Have a great night.